Okay, so hi, welcome back. Previously in 10.1, we talk about area of similar figures. So meaning, right, we are talking about the area A1 over A2, the ratio is equals to L1 over L2 square, because the length, when you square it, it will be the same dimension as the area. So volume being a three-dimensional object, right? So what do you guess? It's going to be the ratio of the length cube. Alright, so it's going to be power 3, right, to match the three dimensions. Okay, but with this, right, this is the expected result. So let us do this activity and really see this is the results that we are looking for. So let's take a look at the first one. So the first one, the volume of a cylinder. Now, volume of a cylinder is, now volume for any prism is the base area times height. So over here, pi r square and h. I'm going to leave my answer in terms of pi so that I can divide that nicely. So in cylinder 1, right, it's going to be pi r square h, right? So this will give me 20 pi cm cube for the volume. Okay, for the second volume over here, V2, this is going to be pi r square. So these are two similar shapes. So pi r square h. So I'm going to get 160 pi cm cube, right? 160 pi 4 520. Yep. Okay, so what is happening over here? Okay, so what is happening over here? Um, okay, so we see that, okay, the ratio, let's take a look at the ratio of the length. Now, this is a times 2, right? The height over here, this is also a times 2, correct? And they are geometrically similar, they are similar figures. Okay, then what about the area over here? No, sorry, not the area, the volume. Over here, right, is actually a times 8. Okay, times 8. So, and 8 over here, this is actually 2 cube. So why do we multiply by 2 cube? Over here, we multiply by 2, but there's an r square. Remember, there's an r square. So we need to multiply by 2 again. From the 5 to 10, we multiply by 2 once. So we have 1, 2, or 3 of them. So here, we multiply by 2 cube. Okay, so this is how we get the ratio of the volume. Okay, so R1 over R2. So let's look. So R1 over R2. So this is going to be half. H1 over H2. This is going to be half. So if you were to match the radius and the height, they are going to be similar. Okay, the lengths are going to be similar. Okay, if you take a look at the volume, so it's going to be 20 pi over 160 pi. So this is going to be 1 over 8. And actually this is half cube, right? 1 over 8 is half cube. Okay, so over here, right, for area, not for area of similar figure, but for volume of similar figures. So given that the ratio of length is L1 over L2, R1 over R2, H1 over H2, the ratio of the volume is L1 over L2, but cube. Okay, L1 over L2 cube. So as we expect, 3 dimension, we cube. So if you look over here, right, so what other things that relate to volume? Capacity. Capacity is another word for volume. Mass is a three-dimensional quantity. So mass would follow volume. We need to cube. Okay, so without further ado, let's take a look at practice now 4. Practice now 4 over here. So we have 2 chocolates. So these are 2 similar figures, 6 to 10 and V1 to V2. So we are looking for V2. So V2 is equals to V1 is 16.2. And then this is equals to L2 over L1. Second length over the first length, but we will cube it. Okay, so this is the relationship we cube for the volume. So V2 is going to be equals to 10 over 6 cube times 16.2. So this will give me 75 cm cube. Okay, 75 cm cube. This one is a cube actually. The volume is cm cube. Okay. Can so mainly like this. So it works like the it works exactly like area. Okay, it's just that now we are working 3-dimension cube. Okay, so over here, okay, I will do the first one, or actually I will do the second one. Okay, and then you can try for yourself A and C on your own. Okay, so we are looking for V2, right? So V2, but I have V1 48 cm cube. Okay, so this is going to be equals to the second length over the first length, but cubed. So V2 is going to be equals to 6 over 4 cube times 48. So 6 over 4 cube times 48. So this will give me 162 cm cube. Okay, cm cube. Volume all in cm cube. Okay, volume all in cm cube. So take note, volume all in cm cube. Okay, so for A and C, I will leave it for you to try. Okay, so they are the same working. Okay, now let's take a look at the reverse case, right? If you take a look at this one over here, I'm looking for R1 and 1. So these are two similar cylinders. So important thing to find out, these are similar cylinders first. They are similar figures. Then we relate to them. So I'm looking for R1. I compare with R2, and I have the information for the volume. First volume is 2, second volume is 16. Then here I need to cube. Okay, so over here R1 is going to be 2 over 16 cube root. Okay, so this is going to be 1 over cube root, so this is going to be 0.5. Okay, 0.5 meters. Okay, 0.5 meters like that. Okay, and okay, let's take a look at the next question. I'm going to do for question B. Okay, in order to solve for the slant length, so any length, okay, as long as the length matches, okay, we can take the ratio of these lengths. Okay, so over here I'm looking for B, so B over 6, so it's the length, B over 6, this is the length, and then I have the second area over the first area. Now which one to cube? The length is the one that need to cube. So the length, when you cube, it becomes 3-dimension. Volume itself is 3-dimension. Okay, a lot of students get confused in which to cube, but the length, okay, 1-dimension you cube become 3-dimension. Okay, so this is how I remember it. So B over 6 is cube root of 54 over 16. So B will be equals to 6 times cube root of 54 over 16. So this would be cube root of 54 over 16. So this is going to give me 9 cm. Okay, 9 cm like that. Okay, easy, right? So it's same like the area one. Okay. Okay, now similarly for the when we are talking about mass. Okay, when we are talking about mass is a 3-dimensional quantity, so it works the same way like the volume. Okay, so over here we have two solid spheres, right? Have a diameter 4 and 5. Given that the smaller sphere, so I'm going to have okay, so this is D1, this is going to be D2, this is M1, this is going to be M2. Okay, mass M. Okay, so find the mass of the larger sphere, so it will be M2, or compare with the mass, first mass, is equals to D2 over D1. And the length I need to cube so that I can match to the 3-dimensional mass. So M2 is equals to 120 times 5 over 4 cube. So this is going to give me in exact values, 2, 3, 4, and 3 over 8 kg. Okay, like that. Okay, so it works exactly the same way as the volume. Okay, works the same as volume because this is 3-dimensional. Okay, so for the practice now 6, I will leave you to try. Okay, and for these 2 questions I will leave you to try. Okay, now I want to talk about one more important thing. Okay, so over here, when we are looking for the volume of the frustrum, so what is actually a frustrum, right? It's actually over here. We have okay, let me move myself somewhere over here, and let me okay. All right, so if you see over here we have a cone, right? But if you notice, the top of the cone is chopped off, right? The top of the cone is chopped off, so we only have the bottom part of the cone, and the bottom part of the cone is the bottom part of the cone is the frustrum. Okay, now what is going on over here is that when we talk about similar figures, right? If we want to look for this volume, right, it has to match the shape. So I need a smaller version of the frustrum in order to match. Okay. However, most of the time we alternatively, if we and most of the time we also don't have the information of a smaller frustrum. So what are we going to do instead? What are we going to do instead is we are going to make use of similar triangles. So we are going to match this frustrum to the whole cone itself. Okay, so what I want you to think of when you look at this question is, I want you to think of this big cone. I want you to think of this big cone and the small cone on top. Okay, the small cone on top. Okay, and what is going on over there is, for this small cone on top, it is just this part over here. Okay, so we just need to minus off whatever volume or whatever mass that we have over here at this part of the cone, right? So that we can actually find the frustrum below. Okay, one more time. We just need to, because the cones are the geometrically similar ones, right? It's not the frustrum is similar to the cone. It is the cone is similar to the cone, right? So with this one, we need to find the volume of the frustrum like that. Okay, so how do we go about this? So let us just use this question as an example. So over here, for the cone, this whole thing is going to be V1. This small thing is V2. Okay, and we have a few details. We can actually look in terms of the height. Okay, we can actually look for the height. We are not solving for anything here. We can compare the height, or we can compare this one, because they are similar. Okay, they are similar. Okay, so we can make use of this the what do you call this, the right angle triangle within the cone, okay, to obtain our similar triangle. Okay, so the volume of the frustrum, how do we find the volume of the frustrum? Is simply just take the big volume minus off the small volume. Okay, very easy. So let's take a look at the example practice now 5 below to really see what I mean by this. So the frustrum, which is obtained, okay, by removing the smaller cone OAB on top with a base radius of 5 cm from the bigger cone OCD, which has a base radius of 20 cm. So over here, let me do some sketch. Okay, so we have a smaller cone. This is 5. Okay, this height is 3. Okay, and over here I have a bigger cone, right? I have a bigger cone over here. Ayo. Okay, bigger cone, and like this. Okay, so this one over here, the radius is 20. Okay, it's a bit different. And then the height, I don't have the height. Okay, so find the volume of the frustrum. Okay, find the volume of the frustrum. So what can we do is that we will need to find the volume for the big triangle first, big cone first. Then we take the volume of the big cone minus the volume of the small cone. Okay, something like that. Okay, so let's see. Okay, let's find the volume of the small cone first. Okay, so volume of the small cone, for volume of cone, it will be 1/3 base area height. So 1/3 times pi 5 square, which is the circle, times the height, which is 3. Okay, so I'm going to leave my answer as pi, so this will be 25 pi cm cube. So this is the small volume. Okay, And let us look for the big volume using the similar triangles. So the big volume over here would be okay, big volume, okay, similar figures are over the small volume. So it's going to be equals to 20 over 5 but cube. Okay, if you want to be a bit safer, so it's a big radius over the small radius cube. Okay, so for the big one, it is going to be okay, big one over 25 pi, right? 25 pi, right? So this is going to be, okay, big radius, so this is going to be 20. Okay, 20 over 5, okay, cube. So the big volume is going to be 25 pi times 20 over 5 cube. So okay, 25 pi times 20 over 5 cube. So this is going to be 1600 pi. So the big cone, the volume is 1600 pi cm cube. So last but not least, the volume of the frustrum, because the question asks us to look for this, right? The volume of the frustrum is going to be equals to 1600 pi, which is the big volume, minus of 25 pi. Okay, so 1600 minus 25, divide minus 25, I have a 1575 pi. Okay, and 1575 pi, so this is going to be equals to in 3SF 4950 cm cube to 3SF, like that. Okay, so this is going to be my working. Okay, so once again, so in order to look for the volume of the frustrum, we need to get the big volume and the small volume, then we minus off these two volumes, like that. Okay. Okay, one more thing to beware is we don't look for the height. So what we do is we don't look for this height. Okay, we don't look for this, like you can look for this height, you can, but normally we don't look for this height to 5 and the whatever remaining, and then we do the ratio with this. Normally we don't do that because this cone is not similar to this frustrum. This cone is similar to the bigger cone. Okay, so this is something that we need to take note when we do questions involving frustrums. Okay, so hope that you are clear and not frustrated. Okay. Okay, so with this, right, I'm gonna leave you to try the questions that which were left untried. Okay, so when we come back, we will discuss all the other questions. Okay, or I will send you the solutions later. You can double check with your solutions. Okay, so that's all for this video. Thank you so much, and we see you in 10.3. Okay.